Good evening, everyone. My name is Luke May, and I'm a rising junior at Montgomery Blair High School. Today, I'm joined with my partners Joshua Soong, a rising junior at River Hill High School, and Adarsh Bharadwaj, a rising sophomore at Thomas Jefferson High School, as a part of BranchOut. BranchOut is a nonprofit program with Veritas Education Leaders that was founded in 2015 and grew from 20 student volunteers to over 150 student volunteers. Our high school student mentors come from over 40 different schools across 5 states.
So we started out as a peer STEM mentoring program working at the community centers, family shelters, and county summer credit recovery programs, and have expanded into a community outreach program to promote cross-cultural understanding by featuring community heroes, creating research articles, and organizing career panels, such as this one. As an award-winning community engagement program, we've received endorsement from the U.S. Congress, including Senator Tim Kaine, as well as former Congresswoman Barbara Comstock.
As part of BranchOut's goals to promote civic engagement, community, and STEM education, we are so excited to be presenting this informative career panel on neuroscience. The field of neuroscience is a rapidly evolving and increasingly significant part of our modern society. Neuroscience is the scientific study of the nervous system and its functions. As an interdisciplinary science, neuroscience combines fields such as physiology, molecular biology, psychology, computer science, chemistry, and mathematical modeling to understand fundamentally how we think, perceive, and move, and treat the many disorders that corrupt these processes. Neuroscience research has led to incredible new technologies and treatments for major causes of death across both the developed and developing parts of the world. Neuroscience has the potential to transform human health and our society in unimaginable ways.
We are delighted to have 3 guest panelists speaking today. One of our featured panelists who will be speaking for us tonight is Dr. Dona Murphey. Dr. Murphey is a neurophysiologist and health justice advocate currently residing in Pearland, Texas. She founded In Phase Neuro, which provides both clinical and hospital EEG services. Dr. Murphey has also done extensive advocacy for the improvement of Pearland's school district. It is an honor to have you join us here tonight. As we are restricted by time, would you like to take a minute to briefly further introduce yourself? Dr. Murphey, would you like to further introduce yourself? Well, it seems like we have a small technical issue. So moving on.
Okay, can you hear me now?
Oh, sorry. Yeah, we can hear you.
I was unable to unmute myself. I think I was considered part of the audience. So,
Oh, okay. No
yeah,
worries.
I think that you captured it. I've started a startup company that is rooted also in neuroscience in part and combines what I've been doing in community advocacy with the physician scientist training that I have as well. So maybe that's the only thing I wanted to add. Thank you very much.
Thank you, Dr. Murphey. So another one of our speakers today will be Mrs. Lauren Schwabish. She is a speech language pathologist with over 21 years of experience providing therapy and rehabilitation to people with neurological diagnosis and the owner of Neuro Speech Services. We are very glad. So could you please take a minute to briefly introduce yourself?
Sure, thank you for having me. So I'm a speech language pathologist, and most people who meet a speech therapist think that we work only in the schools, but I actually work with adults. And my specialty is helping people to work on the cognitive communication skills they need to be able to participate in everyday life. So most of my patients have had strokes, brain tumors, motor vehicle accidents that might lead to a mild brain injury like a concussion. And I see a lot of people who have neurodegenerative diseases like dementia. So it's a super creative field, and I'm super excited to talk about how I got here and how much I really enjoy what I do. So thanks for having me.
Thank you, Ms. Schwabish, for your introduction. Our final speaker who's joining us today is Dr. Julia TCW. Dr. TCW received a PhD and AM in molecular and cellular biology from Harvard University, with research studies in induced pluripotent stem cell reprogramming in the Department of Stem Cell and Regenerative Biology. Currently, she's an assistant professor in the Boston University School of Medicine. We're very happy to have you here with us. Would you like to introduce yourself further?
Sure. Good evening, everyone. Thank you for having me. I'll be happy to contribute whatever question you guys might have. And I'm more focusing on studying Alzheimer's disease, especially dementia, and also diagnose and how the brain function works in people who get the mutation, have a risk mutation, and also further study identifying the therapeutic targets. So we are working on drug discovery and different type of therapeutic strategies. Thank you.
Thank you, Dr. TCW. We are thrilled to have you all with us this evening, and I'm sure you will all provide excellent information regarding the industry for all of us. Our team will ask questions until around 8:45, and then our audience members will have the opportunity to ask questions for our panelists after. Make sure to put any questions you would like answered during the panel in the chat. So let's begin with our questions. So what sparked your curiosity about neuroscience, and why did you choose to pursue the field?
I can start. I had a very personal experience when I was in college. I was already studying to be a speech pathologist, but I wasn't really sure which direction I would go into. And my mom developed a brain tumor. And so I flew back from college to help to take care of her. And fortunately, she survived and she's fine. But after she had the tumor removed, I ended up taking a neurology class, and I was an honors student. So honors students oftentimes, as many of the attendees I know, like to do a little more work. And so I was able to have some one-to-one mentoring with my professor, and I got to touch a brain, and I got to study a little bit more intensively. And I think it was the combination of having a really great professor who was taking interest in my growth and the personal experience of seeing the clinical side of what it looks like when someone has something wrong with the brain that really sparked my interest. And so I think having that life experience, although it was a hard one, was really a growth opportunity. And I think nothing really motivates your learning like having someone that you know who's had something wrong with the brain, or maybe their brain's a little bit different. I think that really motivates us to seek information as to why. So that's what really helped me to get into the field.
So similar reason, I have some personal related issue as well, because my grandpa, who I've been very attached to, he had a dementia at the end of his life, and he couldn't remember me anymore at some point. And I really was curious about like what's happening, and like problem is there's no medicine for this, and that is really sad story that doctors could diagnose, and a lot of neurologist doctors diagnose ALS, Alzheimer's disease, and all those things. However, there are no cure for this, or even like medicine to slow down. And although few neurodegenerative diseases, they trying to fix it and to help them out, but most of the time, even like MD doctors always told me that it's really sad that there's no medicine. So all the rest of my time, I'm gonna just do research to help to find a medicine. So that really sparked me to get into this field, to try to figure out what's going on and to see whether there's a way to find out problem, so whether it can fix it to make the medicine.
I will just add briefly, I had a similar personal experience with a brother who had childhood epilepsy, and ultimately 3 of my 4 grandparents who all had Alzheimer's disease later in life. But they all did. I actually never knew the 4th because he died when he was quite young. So I had a lot of neurological diseases in my family and became very interested in neuroscience as a function of that, and started studying. I think at the time we were just finding out how antidepressants were working in the brain, which was really fascinating to me. And so I think I remember seeing some kind of, I don't know if it was a documentary or some kind of film about that. And that stirred my interest even further. And then I ended up going to medical school and joining a neuroscience lab and deciding to go into not just medicine, but also into neuroscience. I think it was fundamentally informed by those early experiences in life.
Thank you to all 3 of you for sharing your personal experiences. I thought that was really touching and moving, how you just want to help your family, researching something about the brain, something that hasn't been found out yet. I thought that was really inspiring. So our next question for tonight is going to be that some of our audience members may want to pursue a career in the field of neuroscience. So do you think you could describe the training process of becoming a neuroscientist, or how you specifically trained to become one and reached your position today?
Maybe we'll go in order since I probably have the shortest training. So I did an undergraduate degree in communication disorders and a master's degree in communication disorders. So I have a master's degree, and then I did a fellowship, which is required for speech pathologists. A lot of my training actually came from work experience and then self-study. So in my field, you establish sort of a specialty. So I wanted to go into medical speech pathology versus, let's say, going into the schools. But then within medical speech pathology, I specifically pursued working in hospitals in neurorehabilitation. So when you're employed as a speech pathologist, as a clinician, a lot of the continuing education and the training that you do, and then the work experience that you have, is to gain the clinical skills and the evidence-based practice that helps you be the best practitioner you can be. So it's not just what you learn in school, but for me, it was once I actually got out of school and I was a clinician working in large hospitals, that working with the patients forced me and was my motivator to be able to pursue education and training on really on site, right? So I'm either seeking mentors, or I'm talking to physicians, or I'm actually going to the research to see what are the tools and what are the systems that will help my clients to become more effective communicators and thinkers. So I'm sure the other panelists probably have a lot more education, but I was lucky enough to get into neuroscience because of my interest and because of opportunities to work in the field.
Yeah, actually, I sort of agree with Lauren when it comes to that, because I wasn't really labeled myself as a neuroscientist until since 2015, I would say, because the brain is so much complex organ, and because of that reason, and people are really coming from broad area, including computational person to the mathematicians and structural biologists all over the place. And my background is molecular biology and bachelor's, molecular cellular biology, and master's and PhD. And for even postdoctoral training, I did genetics. And at one point that I want to use this skill to study neuroscience in the brain. So that's when I start do research, and I focus on understanding what's going on in the brain, because it's unreachable organ, right? So I wanted to make everyone's human brain in a dish. So while they're alive, before we examining when they're passed away, looking at the pathology, I wanted to look at it while they're alive and see whether we can fix any issues or genetic relevant problems. So even these days, people are in a neuroscience field are welcoming all people from different fields, even engineering, any other field that who've been working on different expertise that can be applicable to brain science. So there definitely is on the college neuroscience program, because a few of my students are coming from neuroscience background and they're way heavily educated, but I don't think it is necessary. It's really more about the personal motivation, I think. Like at one point that you want to work on brain and more to learn all the time. Like even when you start younger or later, it's always fine, I would say.
Yeah, so my training path was, I studied history of science actually as an undergrad, became really interested, I think, in systems, and joined a systems neuroscience lab as a medical student, and then joined the PhD program to extend my MD training. And ended up going clinically into neurology. You don't necessarily have to go into a clinical discipline if you do a combined degree, like an MD PhD, that is like directly related to where you did your PhD, but often it makes sense to do that. So there are a number of fields you could go into actually with a neuroscience degree, and it would make a lot of sense: neurosurgery, psychiatry, neurology. So I ended up in neurology, and my method of choice as a neuroscientist was actually electrophysiology or neurophysiology. So we were doing brain recordings and also stimulation of the brain in non-human primates as well as in people, and studying the relationship between activity of neurons and perception. So we're studying visual systems, and I did my PhD training and my MD training, and then ended up doing fellowship, both clinical fellowship and postdoctoral research fellowship. The clinical fellowship was in clinical neurophysiology, and the postdoctoral research fellowship was in an olfactory, like neuro development lab, and they used a lot of genetically targeted methods to manipulate like specific cell types in the brain, and to see like what consequences they had using a variety of methods. My method of choice was actually interrogating behavior as a function of manipulating the activity of neurons. So yeah, that was kind of my path.
Thank you all for those responses. So what I'm really getting is that there's a bunch of different ways to get into neuroscience, and many people from many fields can become involved in the brain. So our next question that we have here is, branching away from your studies and like into your career, what is the hardest part about your work? Like, what is the most challenging aspect of what you do?
That's a good question. I am a clinician, so I am helping people who are confronted with the diagnosis. So it's not only understanding, but it's helping to explain this information to the person experiencing the problem. So for most of my career, I've been in the hospital. So imagine someone's had a stroke, and maybe they were on a ventilator, or they're just kind of coming out of the very acute diagnosis of that. And then they get to a rehab floor, and suddenly their body doesn't work the way that it used to, or maybe they were in a motor vehicle accident and they've had a brain injury and they can't process their environment. And it was my job, including the rest of my team, to help them to try to start to tolerate and participate in goal-directed activity. So I'm a clinician who's gone from, trying to help someone to just establish arousal, to be able to open their eyes, to be able to start eating again. Maybe they have something called apraxia, which is a motor planning problem, where they might be able to move automatically, but they can't volitionally start things like turning on their voice or reaching for objects. And so that's really the most challenging part, but the most exciting part is helping people to start using their brain the way that they used to and the way that they want to for functional activity, so they can get out of the hospital and go back to being a person again. And then I think a different side, and I'm actually curious about what Dr. TCW thinks about this from a dementia side, is really seeing someone with a neurodegenerative disease process, because we know that they're losing function. and there is no cure. So it's hard from a different way. And it's really my goal and my task to be able to help that person remain, again, as participatory as possible. A lot of what we're trying to do is preserve language and preserve ideas and help that person to remain who they are. But that's hard in a different way because you're watching brain function essentially deteriorate in the midst of, again, a family, a person. So that's hard in a different way. But the reverse side, the rehabilitative side, is super exciting. So that's where you have to take your knowledge of what injury has happened in the brain and how do you translate that into therapy so that someone can help their brain to become more effective.
I'll piggyback on that. So I think for me, lately anyway, it's like trying to translate my neuroscience knowledge to multiple kinds of audiences to make that information more accessible to populations in a way that is culturally and language specific. So like the thing that I'm focusing on right now is actually dementias, specifically Alzheimer's disease, which comprises about 60 to 80% of all dementias. It's the most common kind of dementia. It's something that disproportionately impacts communities of color and immigrant communities included. And yet they don't have the same kind of access to the information, to diagnosis, to care, to counsel. And so, you know, not necessarily putting my science and my physician hats aside, but in addition to that, adding kind of like the work that I've done in the community, which I alluded to at the beginning. That's a new kind of challenge for me. I think it's a very worthy one to undertake. But yeah, that's where I'm spending a lot of my time these days.
So, yeah, I mean, I like to hear other people's opinion. It's always impressive. And actually, this is a really good question and always have to think about it because, you know, daily life is challenge. And in a scientific perspective, the challenge is brain is so complex and it's hard to figure out everything. And we are all the scientists working on it to understand different region of brain, what it does. Even like everyday Cell Nature Science paper, new every week, they're coming out with new type of cells that we have never understand what they're doing. And because of that, like I know that its field is growing. However, for challenging part is that, you know, you think that this medicine might work and target for human, and it actually doesn't work. Many times, I would say 70% plus fail. Even pharmaceutical company, you know, going through all the hard, you know, very stringent pipeline. After all these top scientists evaluate and okay for the going to clinical trial, still 70+% fail. And that is the hardest part in this field, I would say, to find the medicine and really effective work, but we're all working on it to make it happen.
Thank you all for your responses about the challenges of your work. It's inspiring to hear how you are all striving to overcome these challenges to help others and society. So moving on to our next question, what skills do you consider the most important to your job?
I'm going to go first since that's the pattern. Being flexible. I think that it's important to be flexible in your, as you're seeking to understand what's happening, you have to be able to be nimble and flexible in going to the right resources. In working with patients with brain injury, it is very important that you may have a plan. You may think you know how things are going to go, and you have to be ready to pivot at any moment. So that's, I think, very important. You have to be both prepared to go with one plan and then prepare for it to all blow up in your face. I also think as a speech pathologist, it is really important to be able, and I'm sure that actually all the panelists would say the same thing. It's really important to be able to take complex information and explain it in a way that your patients and your family members will understand, because there's a lot of jargon in healthcare and the brain is very complicated, and there's regions and there's parts that we're just barely understanding. But the ability, and Dr. Murphy alluded to this also, the ability for a family member or a patient to understand what's going on in their brain is incumbent upon my ability to be able to explain it in a relatable way. So we do have to have sort of like two sets of vocabulary. I need to be able to read an MRI. I need to be able to talk to a physician and understand that diagnosis, but then I have to take that information and I have to deliver it to my patient who may not have any health education at all, and who also has cognitive communication disorders, and express it to them in a way that helps their experience make sense. So it's flexibility, both in my plans and my actions, but also in my language.
So my field, it takes a long training time. The PhD, postdoc, and like bachelor's degree, finishing the PhD and postdoctoral time, and then you can be PI. That's one career path. Of course, there are so many others, but I would say being a good scientist, good doctor is creativity. But I think that creativity is coming from curiosity. Somebody who is like asking constantly why, you're gonna be a creative person, I believe, because you're gonna find that question. You think it's a very curious person. Because I was like, when I was young, always ask why, even for the question that, why are you even asking why? Like those things is very important personality wise, and also your diligent attitude and, likes to be complete the process when you start. And those attitude, I think, is very good character for academic scientists and even for in the neuroscientists.
I would just add briefly, like a combination of quantitative skills and qualitative skills, I think can allow you to do a lot more than if you're trained very explicitly in one or the other. And also, I think being able to write well, I think probably that will serve you in any career, any discipline. But yeah, as Dr. TCW mentioned, this is a discipline that's particularly complex. And as Lauren mentioned, it's also one that you have kind of an obligation to distill for people. People are very interested in the brain, right? Because everybody has a brain and it explains your behavior and your perception, your emotions, your experience of the world. And so I think we have a responsibility to be able to convey what we do in terms of our research and kind of the insights we have also in terms of the clinical care that we provide to the public.
Yeah, thank you all. I actually thought that the ability for one person to explain something complicated and make it easier for someone else to understand, like Miss Lauren Schwabish talked about, was actually really helpful and relatable on my own, like as a student, So to actually further understand how you guys work in the field of neuroscience, could you kind of tell us what a day of your work is like? Something that, I guess, like an everyday type of perspective of a neuroscientist.
What a good question. I just started a private practice, so I work for myself. So in general, I see today, for example, I'll do today. Today's a great example. I saw 5 people. I have a mobile practice and a virtual practice. So sometimes I'm driving to appointments and sometimes I see them from this office that I'm in right now. I have to do a thorough case study. So today I evaluated 2 new patients of mine. Both of them have been in motor vehicle accidents and they suffer from what's called post-concussion syndrome. And they're both women who have really, really intense jobs. And so part of it is I need to make sure I understand their medical history. I need to gather data. I need to do some testing with them. I need to make sure I understand what their needs are. And then we collaborate to set goals together and plan of care. Another gentleman I saw has schizophrenia. and maybe an early dementia, and he's living in an assisted living facility. And my job today was to help him to use his technology so he could manage his medications. So I helped him to download an app a couple weeks ago, and he is now responsible for logging his blood pressure and his vital signs, and also making sure he's taking his medications, because his medical management has been really, really successful in his ability to function. I have this lovely career panel. I'll be doing a lot of documentation, which is really important to know if you're interested in becoming a clinician in neuroscience and working in a medical setting, is that hospital work, which is where I spent most of my career, requires a lot of documentation and meetings. And so I really want to second that. Really good writing skills is a super important thing, because I have to be able to take not only the information I need, but I've got to crank out a lot of documentation. I'm gathering insurance information. I'm calling families. I'm now, as a business owner, I'm having to market myself. So it's really, in terms of my field, I feel very fortunate that I can sort of mix it up and do something completely different. That's the exciting thing I think about neuroscience, is that there are different ways that we can be in this field. So there's kind of no typical day. And especially if you're working with people with brain injuries, there's definitely no typical day, and it's always exciting.
So let me separate out two different time of my career that I would like to share with, because the scientist life versus professor life was quite different after experience. I'm in a 4th year of a faculty life now, but scientist life is a lot more consistent, which I really enjoyed. Before a professor life is most likely like for 10 years plus, it's like this. In the morning, you get up. Good part is very flexible schedule, because the scientists have to think flexible. So you need to get enough sleep. So nobody really controlling your life. It's not like a 9-to-5 type of job at all. You have a flexible schedule, because your boss is really your material, brain, cells that you're dealing with, what you're studying with. So your actual boss is not really your boss. Your cells are your boss. Because I have to feed them and take care of them. Your mouse is your life. So I have to go when they want my help. So it's not like 9 to 5, I go home kind of thing. So it's like I schedule the way I want. So that's the beauty of this type of life. So I get up in the morning, have a coffee, and start reading papers. What's the newest top paper in the field? And enjoy reading for an hour or two, and check some email, and then go to lab and start doing some experiment. So it takes sometimes like 4 hours, sometimes 8 hours, sometimes 10 hours, sometimes 2 hours. So it's very flexible schedule. So after you do experiment and sometimes prepare the presentation, writing paper, writing grants. So those different things in the middle of the schedule, and that's very routine. The professor job is more about like a management. So I have like 13, 14 people in the lab. So now get up in the morning. I still would like to read the paper all the time. However, it's not always happening that way. It's so super dynamic, because starting with the lab meeting, so somebody present for an hour or two, and then I have a back-to-back individual people's individual project meetings. So I have to guide them. It's more of a management to guide them what to do. So I tell them what, they present what's going on, and I have to tell them what they're supposed to do. And now in the middle of the day, all kind of meeting pop up, and it could be collaboration meeting. So it's like a literally meeting back-to-back meeting with a whole bunch of business meeting as well, financial meeting, and management related meeting. Like for example, microscope broke or it doesn't work. So I have to figure out how we can fix that issue. So it's not just science, it's more about management. Like if something doesn't happen and I have to be there to fix that issue for the rest of people can do the science, right? So it's slightly different. And of course, like a student, teaching as well. like, go out and prepare and give a talk for certain classes and grant reviewing and a lot of other part other than just doing a science and finding medicine. Plus, getting a funding is one of the important part.
I will say just briefly, I'll share what I did today as an example. And I agree with Dr. DCW that this is really different depending on where you are in your training. Now, after I left my training, I actually, for 6 years, was the director of medical and scientific affairs at an EEG diagnostics company. And EEG is like a brainwave study that we do in people clinically and also in research. Then after that, I started my own company. I do similar things. I consult in clinical trials. That's something I was doing today. So sending emails back and forth with a pharmaceutical sponsor about some questions they had regarding the design of how they were collecting EEG data and how the process for which those data would be read and by whom. And then I spent, so I'm building this startup endeavor. It's a public benefit startup that is all about trying to screen and to stage dementia, kind of in not in a medical way, but actually in kind of a more like health education way. So it's kind of self-screening and self-staging, but we facilitate that through a digital platform and deliver tailored counsel to people. And so I have to work on the content, right? Like the counsel that's being delivered. So my partner is working on the content and I'm helping to edit that content and revise, going through a process of revision with her for all of the things that she's creating. Then I'm working on the business end of it. So I'm talking to, like CMOs of other companies that provide clinical services to see how I can support them to support the caregivers that they actually have as clients. Then I'm talking to my advisor for the startup company, right, who's helping to give some guidance on how we structure our entity. I'm talking to our lawyers who are telling us about filing for status in Delaware, right? Like, and then also talking to our developers who are actually working on the development of the app that we're building. So it's very varied. It's a lot of fun, but also can be a little bit stressful. You have to be comfortable, like just kind of moving in all of these different spheres to put something together that you really believe in, right? Yeah, that's what I'll say.
Yeah, thank you guys for that. I think you really provided insight onto how, even though you're all like in neuroscience, you really have different like different daily routines, and you all do different things to help everyone. So I have another question. So how does your work in neuroscience impact your community or society as a whole? What do you feel is like your contribution to the people?
I feel like as someone who's a clinician in the community, I feel like I am a resource for physicians and referring partners like neuropsychologists and psychologists and physical therapists, people who are in the community who meet someone who has a neurodiagnosis, who's looking for services. I feel like I serve a value in that way, which I think is really important. I feel like I'm just making, and this is one of the things that I enjoy by starting my own practice, because when I was in the hospital, I was in a position where I was helping to train new clinicians to be the best clinicians they could be. So I was doing a lot of teaching and a lot of mentoring, but I wasn't seeing I didn't have a lot of caseload, right? I'm like these other professionals where there's all these other things you have to do. They're more administrative. And so I chose to really return back to clinical care. And so I think being a resource for one individual alone is so rewarding. So just by meeting one family member, by meeting one patient, I feel like I'm making big differences. I'm helping what's oftentimes a very scary and frustrating situation to become more manageable, and for people to feel successful with a neurologic injury is also really exciting and rewarding. And then I get to do stuff like this when I get invited to talk to students or to other community groups about what I do and how people can help to take care of themselves. So I do a lot of community health education, in particular focusing on cognitive wellness. So helping people to really understand how to take care of their brains. I think is something that, like Dr. Murphy said, we all have a brain and it all explains how we do. And especially when we have, unfortunately, not a lot of pharmacology available for Alzheimer's, a lot of the there is a good amount of work on drug development, but there's also a lot of people who are very invested in behavioral changes, like looking at things like managing their blood pressure and their blood sugar and being able to engage in cognitively meaningful activities and get the social stimulation that they need and the good nutrition. So I do a lot of sort of stroke prevention and cognitive wellness education with people who really want to know what is tangible, what can they hold on to, what's within their grasp to make their brain function as well as possible. So kind of from the individual to the community, I like to do a lot of education and be a good resource.
I think Miss Braun Schwabish is really the actual, field educator. I believe that's amazing. I always admire those type of people, and because really actually contributing to the communicating with the society. Me as a scientist, doctor, is two aspects that I'm really working on. Communicate with the community and contribute in the field is that one is knowledge creation. I do have MD PhD student, PhD students, a lot of undergrads as well in the lab that I can in-house educate them, make the best scientists and doctors in the field. But we have so much of unknown knowledge that we are working on to identify some novel aspects that we write a book, college, create a new books to educate MDs and PhD scientists to learn something new. That's one aspect. So we constantly publishing, try to publish novel idea and novel concepts to publish in the field, and hope to translate in a community as well. So educate what is new. And the other aspect that I'm really working hard on is to find a medicine to really actually that can go into the clinical trial and pass that to really work using in a clinic. So hope that can happen soon.
Yeah, I will say quickly that part of what we're trying to build with this public benefit startup is connecting people from communities of color to clinical trials, because there has been historically a lot of under recruitment or lack of representation in those trials. And that's really problematic for clinicians when we try to give advice to patients about medications and their efficacy as well as the side effects that they may experience, because that sometimes is actually based in race and ethnicity, and not having enough diversity in clinical trials, then it undermines our ability to actually advise appropriately. So that's one thing I'm doing in that domain. But the other thing I would say is that in general, my background as a systems neuroscientist, and I think also as a historian of science, and both things I think are very much related, because both things think about integrating signals, right? Integrating information. And they're both very multidisciplinary, I think, in that way, thinking about how a lot of in history of science, it's like how social forces, historical forces, economic forces, political forces shape the development of science over time. And in neuroscience, I was specifically a systems neuroscientist, but I think that discipline in general is very much interdisciplinary. And so you're trying to integrate all of this different information to have a full picture of the brain. And I would say that further bleeds into the work that I do in the community outside of the startup that I'm building. I serve on a bunch of boards that are very politically engaged in many ways, Doctors for America, Doctors in Politics. I serve on the board of an immigrants' rights organization, a citizenship justice organization. And I think the way that I lead in those organizations, it really is modeled after how the brain functions. So the brain functions in terms of distributed networks, right? And that actually makes it a very powerful organ, like the computational power that is possible with distributing information like that and distributing computations like that is really pretty amazing. And I think that similarly, when you have diversity of inputs, right? When you're leveraging inclusion, collective intelligence, that you can build something that's much stronger in terms of whatever system it is that you're building.
Thank you all for your answers. It was wonderful to hear about the positive impacts that you all have on our communities. So we have one last brief question before we switch to audience questions, and we are running a little low on time, but what do you believe the future of neuroscience holds?
I will probably defer to my other panel participants, but I feel, I mean, the science is incredible, right? So I think that people are going to really have, I think people are going to have more access to understanding how their brains work. And I'm hoping to see, in my particular field, I'm hoping that we can start to get some biomarkers or some other ways of imaging that may be better able to help us to understand disease processes that at this point you may have to wait till autopsy, or you may have to wait till some clinical symptoms are so advanced before we really get a good picture of it. So I think being able to be a clinician like me, who's just trying to help a client understand what's happening with their brain, that will have more usable information. And then I think there's also some non-invasive technologies that are at this point in research. So like transcranial magnetic stimulation is something that some of my clients might ask me about, and I'll say like, ooh, I've sort of read the research on that too, but I don't have one in my clinic. And so I think having more clinical tools to be able to offer to people, both for diagnosis and for treatment.
I totally agree with you. It's gonna be very exciting because there are so many ways actually we can diagnose diseases even from saliva. Actually, you can get the genetic as well as you can find biomarkers from this, like without any invasive method. Getting a saliva, a little bit of it, is not a big deal, right? We test for the COVID as well these days, and you can pull so much things out of it just from the whole population. And if you can also match the genetic and get the patient blood, and you can actually recapitulate and make a stem cell and look at your brain, how your brain works while you're alive, before we get to the, diagnosis and going through the disease status. We might be able to capture things earlier, or even brain scan, and using the parameter of a dish of brain, and you can capture what's going on. And we can even create therapies of like using CRISPR. Like there's a CRISPR, actually you inhale it and it can go into the brain right away and fix that issue. And there's so much exciting like engineering brain type of work is ongoing in the field. So I think, like future, we have to solve a lot of brain disorder. That's what I'm hoping. So we can be living healthy for a long time.
I'm super excited about the potential for neuroscience to influence like just everything, right? The more we understand about the brain, hopefully, I think we can transform how we do K through 12 education, for instance. I feel like the potential impact that neuroscience could have in like understanding the hijacking of the attentional economy that happens right now on social media platforms that causes a lot of division, right? And polarization politically. I think people in general having a better grasp of that and things changing as a result. That's very exciting to me. Yeah, and then I think also definitely like in the domains of all of these different diseases, that's so important, because we have a lot of people who are aging now, and a lot of neurodegenerative diseases that are going to have huge societal impact. And I think the more we understand about how we can potentially intervene and stop the progression of those diseases or to prevent them altogether, that will be really important too.
All right. So thank you, Dr. Murphy, Mrs. Schwabish, and Dr. TCW for the valuable insight on the field. So since we are running low on time at this point, if any members of the audience have any questions or clarifications for our panelists, you may feel free to put them in the chat box, and I think we'll try to get to as many as possible, as many as time allows us.
Yeah, so our first question from the chat box is, what are some recent what is some recent breakthrough research that has been discovered in the field of neuroscience that's really impacted all of your work?
I will say that the concept of neuroplasticity, the brain's ability to really be able to make new connections, is it's not new per se. It's probably not the hottest topic, but it's something that is really a very motivating factor. And it's a nice way to translate what the science says to motivate patients to take action in therapy. So one of the basis of neuroplasticity is novelty. And so you need to take someone and really challenge them to be able to come up with something that is new and novel. And then another basis of neuroplasticity is repetition, right? So we don't get better because we do something once. We get better because we do it over and over and over again. And we pick up the challenge as things become easy because our brains need to really be able to stretch to make those new connections. And I think that that is a concept that is a really powerful tool for driving change in brain performance. And I will say it's very motivating for people who start to understand that their actions should lead to changes in their brain, which again, the brain is an organ, we all have it, but we can't see it. So when you're asking someone to do something, people are starting to hear about it. So I think that it's my favorite.
I think the biggest breakthrough in the field, in the science field, is iPS cells, induced pluripotent stem cell. That is a concept of converting any somatic adult cells and reprogram back to embryonic stem cell, so that we have a capability to differentiate any brain cell type. So we can recapitulate brain in a dish. So while we are alive, we can actually look at the person's brain. That's received a Nobel Award in 2012, I believe. I think that is because these are human cells that carries all the human genetics. So we don't need to really focus on working with the mouse cell anymore, but rather we can focus more on a human system. So that is, I believe, is a breakthrough in the field.
I'm just going to plug really quick, like optogenetics, chemogenetics, like all of these genetically targeted methods to specifically activate like subtypes of neurons in the brain, I think are already, those methods have already been very powerful. And I think that we will discover more and more by doing systematic surveys of like what happens when you activate or when you deactivate certain cell types in the brain at different time points.
All right, thank you for your responses. It was very interesting hearing all these novel discoveries and technologies. So I think this will be our last question for the panel. So I think a lot of our audience wants to know more about like opportunities for high schoolers or undergraduates who maybe want to pursue careers in the field of neuroscience. So what advice would you have for like the younger people?
I actually first met a speech pathologist when I was in high school, who came to my high school to talk to me. She was someone who specialized in head and neck cancer. And so she was showing us laryngectomies. And I ended up contacting her, and I was able to work in the Manhattan Eye, Ear, and Throat Hospital over the summer as an intern. So I think meeting someone who does what you would maybe be interested in doing, and just introducing yourself and asking for opportunities, you know, being able to see professionals doing what you would like to do will give you a real sense of if this is something that sparks passion, or if you're like, I don't know if I want to work in a hospital on Christmas every single year for many years in a row. So really talking to people, you know, as we are all taking time to chat today, like people are excited to tell you what they love about the field. So I think by having an opportunity to shadow, especially, or even just learn more about the pros and the cons or the ins and outs of what it means to do the work that we do. So I would say find someone and just meet them and ask them.
So I would advise you to think broadly, she mentioned that like neuroscience is a big field. Like there are so many routes that you can go and study and different type of techniques. And it doesn't always need to be MD doctor. There are so many different parts that, it's a really, complex, and so many experts has to come together to understand and, figure out the brain. So think broadly, and if you're interested in brain, check as this panel is amazing panelists, and there are so many different career paths that you can consider, and see whatever you excited about, and you can just dive into it, and it's gonna be good.
I highly recommend a book called Designing Your Life by, I think, Bill Burnett and Dave Evans. There are a couple of professors at Stanford, and that's the name of a class that they teach that apparently was super popular for Stanford undergrads. And it is about applying design thinking to your choice of careers. Yeah, neuroscience is very, very diverse. You can end up in so many different areas in industry and academia and government. Like you could go into things that are not even ostensibly related, but you can really powerfully apply your neuroscience knowledge still. So I think it's important then to really understand like what it is you want from a career, and to be more values and process oriented in your thinking. And then, knowing also that you're interested in the brain, and putting those things together over time, also spending time with people in the community and shadowing them to get a real sense of what these careers are actually, and not just in the abstract in your head. And thinking about the other things that you want in life, right, that are not necessarily directly related, and what impact those things have on a particular career path in neuroscience. Yeah, that's probably the advice I would give, is check out that book, because it really, I think, is a different way of thinking about a career.
All right, thank you all for the great advice. Unfortunately, that will be all the time that we have tonight for questions. So maybe if the panelists could put their contact information in the chat so that our audience members can have their unanswered questions answered, that would be great. We want to thank all the audience members for their participation and great questions. And before we close out, we would like to give the panelists the opportunity to share anything else they want to say, or any final suggestions or advice to anyone that may be interested in pursuing this field.
I think you have to just follow your passion, which sounds so cheesy, but the fact is that it's a lot of work to be a professional in neuroscience. The study is rigorous. If you're working in a clinical aspect, it's a nonstop learning process. There's always new research. There's always, in healthcare in general, as Dr. Murphy's kind of alluding to, there's a lot of inequality. There's a lot of change. There's a lot of things that are going on that are not right in our healthcare system. And it's unjust in a variety of ways, but it can really adversely impact people who have cognitive communication issues. So I watch people navigate our healthcare system who may not be able to listen or to read or to speak, or maybe not have the endurance because of their nature of their brain injury. So things are hard. So I think it's a lot easier to navigate it when you are excited and you are passionate. And so the challenges are things you run towards instead of have to deal with. So I think if this is something that sparks interest in you, then nurture that through the ways that we've recommended. But you really do have to be passionate about it, because it is a challenging, it's a challenging field if you're not really on fire about it, as we all are.
I think these group of people are already great, because you guys are curious about already this career path and spend time in listening to this kind of talk, and you're already in advance. So what I would recommend is that, like if you're passionate about something and you read the paper and you're curious about something, then just don't stop it, and don't get afraid of things that, you guys already have us here. And just reach out. There is always email address then, or LinkedIn, or any other social media you can use, and reach out. If they don't respond, don't feel uncomfortable about it. Next person, like somebody gonna respond to you, and you can get exposed and like ask whether you can experience about it. And is there anything, you can recommend? And, from there, like sometimes, you think about it 1,000 times, but you're not still sure. You experience in one day, or people in the lab or other place that who actually have that job might give you better insight, or you actually expose yourself and see whether you can have an internship or something so that you can get exposed and really experience it. And you really know that you're going to like it or not. So you want to be more proactive about your life, and you're going to get you it's going to get you somewhere. Thank you.
I have no further wisdom to add. You guys covered it. Thanks everyone for joining us.
All right, so thank you to all of our panelists for your informative responses tonight, and as well as your wonderful conclusion and your closing remarks. So we now like to take a group photo with our panelists and our audience, and it would be much appreciated if everyone could please turn on their cameras and smile maybe for like a few seconds so we can all get a screenshot, which we will probably post on our socials, or you can find in a moment in the chat box. But I guess let's all turn on our cameras and smile, and I'll let you know when the picture is like taken. So,
on behalf of the whole BranchOut Career Panel team, we hope that everybody has enjoyed the panel this evening and learned a great deal about these successful individuals in the field of neuroscience. We hope that everybody got a chance to learn more about neuroscience, have their questions answered, and perhaps even become inspired to learn more about this industry. Neuroscience has become a vital part of our daily lives, and it will continue to be so for generations to come. Thank you.
Again, we are extremely appreciative of our panelists for taking time out of their busy schedules to give us such great insight into this field. So thank you guys so much. We would also like to thank our team members that were behind the scenes that work daily for making this possible. And we would also like to thank our audience members for making this possible as well. Thank you all for joining us tonight. To learn more about BranchOut and our future panels, please check out the links in the chat below that will be pasted. Be sure to like us on Facebook at Veritas Education Leaders and check out our other social media platform. So be sure to also look out for the next career panel, which will be on chemical engineering.